Hello and welcome everyone. So today's video is going to be about backtesting a strategy together, and we are going to do it on the instrument called Banknifty. Okay, the data which we are going to use is 1 hour interval data, and I'm going to show you how you can backtest a profitable trading strategy, and not just profitable, something that sustains the profits. Okay, last thing which I want to make a complete disclaimer is, number one, this video is about improving your coding skills, right? And increasing and expanding your knowledge about backtesting and other processes which are a part of algorithmic trading. Okay. Now, when it comes to algorithmic trading, you just don't have backtesting. You also have other things like forward testing, uh, quantitative research that leads you to the indicators and the various, mathematical inputs used for the backtesting and for the strategy. Okay, but at a prime level, where at a primitive level, where even the basic person can understand, so for somebody who has a basic knowledge of trading can understand, the steps we are going to take is, number one, we are going to take ideation as the first step. Is the the first step being, how do I create an idea and then lead it on towards coding. Okay, the next is we're going to handle a lot of data. So data is where our idea is going to be running through, and while we're handling data, we learn how to manage the data first, and so that we are able to code onto the data. Okay, and number three, we're going to see graphically. So we're going to visualize the results which we're going to get, and we're going to do a number of things and try and find out good results. So it's going to be a nice video. You can code along with me. Today, I'll be particularly using PyCharm for coding. You could also use, and I normally do it on Jupyter Notebook. It's just that this is been coding recently a bit too much, and my fingers are paining. So PyCharm is much easier that way. Okay. So anyway, let's begin. Starting first thing first with the idea. Okay. So allow me to share with you the chart, the price chart. Okay. 1 second. Yes, first we're going to start with, hang on. 1 second, please. I'm sharing with you the chart. I'm going to understand what our idea is. Here we go. Okay. So we're going to understand what our idea is. So this is the hourly chart of Banknifty. Our testing period is going to be 2 years. And this is the hourly chart because on this is the data on which we're going to actually work on. Okay. So first let's just plot what we need. We're going to have moving averages, two moving averages particularly. One will be the 20 period moving average, while the other will be the 100 period moving average. Okay, let me color the 100 period moving average in a different color. Say for example, we'll do this as black, so you can clearly see which the 100 is and which the 20 is. The 20 period moving average is the fast moving average. The 100 period is obviously the slower moving average. And I want you to bring your attention over here to a particular topic which probably a lot of you are already familiar with. It's called crossovers. Okay. Now this video is not about a crossover strategy, but we're going to derive something interesting from the fact or the essence of crossovers. Okay. So crossover occurs at the point where the slow moving average, the faster moving average crosses the slower moving average from below, or the faster moving average crosses the slower moving average from the top. Okay, so these are two crossovers. This is obviously more bullish in nature, right? And this is obviously more bearish in nature. Right? As I said, our prerogative is not going to be trading of crossover, but we're going to understand the essence of it. So once the crossover happens, and suppose we're looking at an overall uptrend after the crossover happens, what we tend to see is that there are times when the market is above the slow moving average, the faster moving average, which is the 20 period moving average, and there are times where the market is below the 20 period moving average. Okay, so understanding is going to be the first thing about our idea is going to be we're going to take a period of time as our entry point, and then we're going to zoom in to just one candle. The close of that candle is going to be our entry point. Okay, so the period of an entry point, what do I want as one of the major filters of my candle is that the price, which is the closing price of the candle, should be greater than 20 moving average as well as greater than the 100 moving average. Okay, so these are the two conditions which I want to be true. The second thing is that the fact should be that above the 20 moving average, not just the price is not going to be just above the 20 moving average in that particular day. We're also going to check that if in the last 20 days, and when I say days over here, I mean hour or bar or candle, okay, that in the last 20 bars, at least 10 bars were greater than the 20 moving average, as in 10 closes were greater than the 20 moving average. Okay, makes sense. So say for example, I look at the picture over here that the price is above the 20 as well as the 100 moving average, right? And when we're going to zoom in to the candle we particularly want, we're going to make sure that the last 20 out of the last 20, at least 10 or greater than 10 bars have been above the 20 moving average. Okay, we're going to add another filter over which we're going to do so by using Bollinger Bands. Now what happens is that I might get signals over here. I might get signals over here. Say for example, I might get some signal over here. Okay, all that is great. But I don't want a signal which is an extreme signal, which is happening at a point where the price is already very bullish. Okay, so one of the filters which I'm going to add over here is via Bollinger Band. Okay, now a lot of you over here are familiar with Bollinger Band, right? And there's a lot you can do, believe me, with moving averages and Bollinger Band if you have the right perspective. Okay. So number one, what we are going to do is we're going to look at this Bollinger Band and see, observe certain things. Here, I want you to bring your attention to this point. Okay. On this particular bar, okay, we see at this particular bar, we see that the low of this candle is greater than the upper band. So this is the Bollinger Band, this is the upper band, this is the lower band. This is the upper band over here. So the low is actually greater than the upper band. Okay. So what happens in such a situation? This is signifying to us that the volatility is too high and the price is moving powerfully. Okay. In another context, I could have gone long over here and said, okay, fine, because this is so powerful, there's some more up move expected. But here, this is not a context. Here, we're going to filter out this area. We don't, we want that the low of the particular candle which we enter should be lower than the upper bar. Okay, so it should be in the upper area, like as in the area between the upper and the middle bar, but it should not be greater than the upper bar overall. Okay, next thing, we're going to add another filter for which we're going to use RSI. Again, to avoid the extremes, so let's take RSI, simple RSI over here. Again, a lot of people watching would be familiar with this. Here you notice RSI is not 70. Okay. Likewise, there are points in the market where the RSI just goes berserk. Right? This is around 89. Okay. Almost 90. So I'm going to add a filter, and that filter is going to be that in the last X periods, RSI has not crossed, has been less than 90. Okay, so just to make sure that we are not getting into any price extremes. Okay, so we're going to take the coding work slowly and steadily. Allow me to share my screen, the pie chart. Now, if anybody over here is actually viewing this, you can actually make sure that you are, uh, coding along with me, right? So first and foremost, let's import the important packages. Let's import this. Let's import pandas, this PD. Let's import numpy as MP. Let's also import datetime. Okay, and also make sure that there will be certain warnings which perhaps would be not something like. So I'm going to do what? So I'm going to filter those warnings and ignore those warnings. And right now, for the purpose, sometimes the warning can be actually important for us, but for the purpose of this video, I'm going to just focus on ignoring those warnings. So warning dot filter warnings have time. Okay, so ignoring those warnings. Now, because our data is going to be in such a time format that we need to do things with it. Okay, we are going to import a package from a package called pi time zone. We're going to import time zone and we're going to work around that. How? That I'll show in a bit. But before we come to that, one important thing I have forgot to import is importing matplotlib.pyplot. Okay. PLT. And also, second. Absolutely. Okay. So this should work for us, and we should be good to go with. Okay. So warnings that filter warnings, as you can see in here, it's showing me as okay. I think this should be fine. Okay, fine. Okay. So let's just run the code. It's an empty code. Nothing is going to happen. Just make sure that we imported everything. Okay. So now we're going to do something with the first thing which we need to do is we need to get our data, right? So I have the data set on a CSV folder, the CSV file, which is on my desktop, and the file path to that I've already copied. So I'm just going to paste that file path so that it becomes easier for us. And we're going to do something with the data. Okay, I'm going to first create a function. Now let's name it require data. Okay, we're not going to pass anything in the function. This require data is directly going to give us what we need. Okay. Let's just call this as data equal to pd dot. Okay, so what we're going to do is we're going to read CSV and we're going to read this file name person. Okay, so read CSV, read underscore CSV, and instead of giving the file path in here, I'll just put the variable file path here. Okay, and in the end, it is going to return us the data. What we're going to do is check out how this entire thing runs. So let's come to this. Let's name our variable df, which is going to be a data frame, and let's call this function. Okay, so this will read the data. I forgot to do this. This is PyCharm, not Jupyter Notebook. So I'll just print the df.head function and let this come out. Okay. We see what the output is, and this is the output. Okay. See, there will be number of columns, and I need only certain columns. Also, one of the issues is that this time is in a very weird format. Most of you cannot understand what this format is. So I'll just tell you how we're going to play around with time and going to make sure that our time looks amicable and it looks something like you can work with and observe, as well as we can code it later. Okay. So a few things which we need to do is first, let's just take out the columns which we need. Okay. So over here, I'll need okay. OHLC, right? So good about open also, one of the important things is time open. Open time no no and uh, as it happens so that PyCharm always follows the tablet format, so you can't get untidy with the code with the code, right? And now we're going to run this program again, see what we have this. Right? So we've got the necessary columns. We'll see that we've got the necessary columns. Okay, so let me just pass it to show. Okay, so we should be getting the right. Oops, spell this. Okay, prepare data is going to file says. So prepare underscore data. Data is going to print this data. Okay, let's do it. So data. Now it's going to run. Check out what is it? Extra brackets. Okay, so here we are. We have our time. We have open, right, no close, exactly the way we need it. However, there's something a little off about this. And what is that? We don't have the right format of time. It's probably we may want to, if we want, we can work with the index, and that will be completely fine. But maybe we want a better way the time should be presented, right? So since we've already imported date time, we're going to do what? We're going to use the PD2 date time. So let's just get possible here. So, and we convert the time column and we pass the time column and we write unit equal to seconds and run the program and see if we get the time. I think there could be a small issue. No, it's not. So yeah, we've converted the datetime format, but there's another problem. The first candle or the first candle of the day should have 9:15 stamped rather than 9:45. Okay, and the market is generally closed at 6:45. So how are we having this, right? Because this is the correct format of time. However, we are not in the right time zone. So I know this can be a little boring, but while it's boring, these are the small things that you need to make sure. Okay. So what we're going to do is we're going to change and we're going to localize this time by using the one second, the time zone function. Okay. So this time is equal to just a second. So we're going to take the date time column of data and dt. So this is going to be the time zone dt dot dz, and we're going to underscore localize. This is the right syntax, and we're going to make it UTC. Okay. So let's see if this works. And if it does, very good. One mistake down here. If that did not try to do it properly, and really sorry for that. So here we have converted it into the PC time. Perfect. But again, we need to convert it into the Asia time zone or the Indian time zone. Okay. So what we're going to do is we're going to, now that we have localized it, we are going to convert it by using the TZ underscore I think we're going to use the localized function, or we'll use the tz underscore convert. And within time zone, right? Asia slash code. Then the return data is happening. The spelling mistake and shift F10. Now we should go. So our data is prepared. Yes, you see this is 9:15, 10:15, 11:15. Now that you put a data, this function is going to be, eventually this function is going to be called again. So let's just remove this for now. And let's go to the indicators. So let's make another function called coding underscore indicators. Our indicators are being one of the indicators that we need. We need the moving averages. So let's just go to moving averages first. I'm not going to make a for loop and make too many moving averages. So I'm going to just show it in a simple way. So the 20 moving average will be 20 ending, which will be the habit of writing data for me. So let's just write data is equal to data close dot rolling. And within that, it's how much rolling? 20 period rolling moving average and rolling. So we created the column for the moving averages 100 MA now. So we do the same thing basically. You could have just copy pasted it, but I'm just showing it to you step by step. And dot rolling 100. Okay. So we have got this. Just do one thing is we run this code. What we will do is return data, right? And just to check out if everything working fine, a small health checkup of our code till now. Let's just do this. Guidelines. Okay. So let's just say that df is equal to prepare underscore data, and it is. Then let's just say this run the coding indicators function and pass the df, and lastly we'll print our data frame. The head of a data frame, there's the top 5 rows, right? And let's run this and let's see what we have. Did we get these indicators or not? So yes, we did. And as you can see, there will be a lot of NaN values, but it will take at least 20, 20 plots to actually get the first moving average, or first 20 moving average, at least 100 plots to get the first moving average point for the 100 moving average. Okay, so it's okay if it is not a number value. Later, we will do the use the drop any function, and we are going to create drop any function. Okay, so anyway, now moving on to the other indicator which I need a Bollinger Band. Okay, now Bollinger Band is what? Bollinger Band is two standard deviation. So with the upper Bollinger Band, we don't have anything to do with the lower Bollinger Band. So let me just type this as data upper. Okay, we don't need the lower Bollinger Band, so I'm not going to do that, although ideally I should do that just to make sure it is in my entire function, but that's okay. So what we're going to do is we're going to, how's the upper band formed? The upper band is two standard deviations above the 20 moving average. So the upper band is going to be basically data 20 MA plus what? Plus 2 multiplied by data close dot rolling STD is for standard deviation. So the rolling standard deviation 20 period, and we have the upper band also with us. So once we run this program again, we see that the head of the data frame has on the upper band too. Okay, so here is the upper band. So 2 multiplied by this. Okay. So all in all, this is what we need. Okay, we also wanted to code the RSI. So just to make things a little quicker, what I'm going to do is I'm going to simply take code which I already have, and I'm going to just put it there just to make sure that you guys have understood. And I'm going to explain this to you. You can, those who are coding with me, can actually work this out. So here is the 14 period RSI. So I just made a small list of RSI which has only one, a period called 14 period. And through this list, what I'm going to do is that first I'm going to get the gains of the 14 period. Now here, the gains of the 14 period is going to be done through a lambda function with the dot apply method. Okay, so data gains is equal to the close minus the open dot apply lambda x if x is greater than 0. Okay, so only those gains are going to be taken through the lambda function which have x greater than 0. Okay, and that value is the only value being shown on the gain section. Then in the losses section, we're going to take the days where the close was greater than the open. Sorry, the close was lesser than the open. So the price opened higher and it went down. Okay, and therefore we finally calculate the average gains, and obviously the average gains we need to calculate is for the RSI period. So here for RSI and RSI list what we written, and therefore the RSI list being having 14 over here, the number 14 should come up here. So if I just kind of remove this entirely and just write 14 over here, my job is done. So 14 period mean of the average gains, 14 period mean of the average losses. Then what I'm going to do is to find the relative strength, which is the RS. So for that, what I need to take is I need to take the data, just naming it as 14 average gains. Okay. So this is the average gains, and the 14 average losses. Okay. This str is converting this into a string, and we are doing this as a plus. So 14 average losses, 14 underscore average underscore losses, right? Likewise, 14 underscore average underscore the other. So here again, so wherever there is RSI, I'm just denoting as 14. So you can understand we look at the 14 period RSI. Okay. So moving on. Now all of this could also be used, done by using the TA library, but for the sake of a better understanding of the code and a better understanding of the internal mathematics, I chose to directly show you the calculation. Okay, and then finally we are returning the data. Okay, so all in all, well understood. So we've got our RSI 14 in the end, and let's run this program and we'll see. Those who are having any kind of trouble, errors are shooting, you can just simply pause the video and check out what is wrong. Okay, so from where I had copied and pasted, the column name was a capital close, a capital open. So I'm going to just turn the capital close and capital into smaller case close and open. And now the program should run fine. So in the end, again, we have got a print df.head. So we do have a average loss, average profit, etc., etc. And what we need over here now is we need to drop the value. So let's just make the data equal to data or we can just say data got drop in effect, and we can make it permanent by saying int is equal to true. And what this line of code is going to do is going to permanently delete the not a number values, and we will have the full value. So again, run the program by pressing Shift F10, and here you can see the values are there. So this is the RSL14, right? RSL14. Somehow we have two columns. Oh, this is RS. This is RS. Okay. So this last column is on focus. Right? So if you just want to check out any one or two, you can just check to print those columns and check out how things are going. Right. So this is coding our indicators. So now in the modulo, following the modulo format again, we're going to code the conditions. So let's write coding conditions and create a function. So the first condition, what did I tell you, was that we need to check out. Let's go back to the drawing board once. So let me just share with you the whiteboard again. So it's assume that this is the price. Okay, this is how the price is moving. And there will be obviously the 24 moving average, because it's first into the moving average. And there will be the upper bound somewhere like this. Right. So what we need to make sure is first our focus is going to be the condition that it sustains above the 20 moving average for at least 10 out of the last 20 candles. So for that, I need to first talk out which are the closing prices above this red line, which is the 20 M. So first we're going to write a condition to filter out the candles which are above 20 M. Then you're going to do something, find out which are the candles that are not just above 20 M, but they have in a way that they have sustained above it for a significant period of time. So let's just make another point for data. So this coding indicators in coding condition just takes in data and you can code data. Let's just name this column as above 20. Okay. So it is a bit descriptive. I'm not commenting everywhere. I'm not making comments of different kinds while I'm coding, just to keep our process short and sweet. But while you're coding, it is a best practice to make sure that the codes are well commented and that you have even described the function. So somebody else who may be seeing this function in your code can just do a prepare underscore data question mark and find out what is inside. Okay. So just say, for example, it goes like this. It's a bit different than anyway, so we'll do one thing. Which side? Okay. So, so now I'm just going to run podcast just to show you how this thing works. So let me just keep it like that and show you in the end if I get time. So let's just keep it like that. Till now, everything working fine. And there we go. Okay. So let's just get back to now. I'm more used to it than doing that range of course. So anyway, sorry to slow down. So data, wherever the close is greater than the 20. Now, let's just understand this. I have named this column as the 20 column, right? Now, I'm going to use a particular method called the np-where. np.where this condition is taking place is going to be encoded as 1 or else it's going to be encoded as 0. So I use the np-where function for that. So above underscore 20 is the first thing which we did. Now we know that everywhere the price, the closing price is above the 20 moving average. Data column above underscore 20 is going to be equal to 1, right? So how do I make sure I know it was sustaining above sustaining underscore 20? Now for that, again, we're going to do np.where. And we're going to use our brain and we're going to make this into a turn this into a logic. Underscore 20. Okay. The rolling sum. So that means the last 20. We're going to take the rolling sum. Okay, just a second. We're going to take the rolling sum. And we're going to say that this rolling sum should be greater than 10. And everywhere this is true, let's encode this as 1. And where it is not true, let's encode this as 0. Okay. So these are going to be our columns, and we're going to eventually return data. Okay. Yeah. Yeah, just a second, guys. Just a second. Moving on, let's move on to the next condition. One of the conditions that we want to happen is again that it should be also above the 100-day moving average. So we're going to name it similarly above underscore 100. And we're going to say that this is going to be not where the data close column is greater than data 100. Okay, so this makes sense, right? And we will encode wherever this is happening as 1 and this as 0. So these are 3 conditions which we had already discussed, but I just hope now this is more and more clear to you. So what does rolling dot sum do? Let me describe it to you. What is rolling dot sum exactly doing? So it is shaping a rolling sum. As I said, every time the 20-moving average is above the close, the close is above the 20-minute average, it is encoded as 1. So this is 1, this is 1, this is 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1. So I take a rolling sum and take the rolling sum of 20 means take a block of 20 such ones or zeros, and then the next row, I'm going to take the next. I'm going to drop one from here. I'm going to take another extra one for completing my 20. And so on. This rolling sum will be this. As this rolling sum is 20, I'm going to check wherever this rolling sum is greater than 10. And it is pretty much obvious I'm saying, when I'm saying that once we have taken a trade, we are not going to take another trade. So maybe the condition is being met uh, after that also. But suppose we take the trade over here, we're not going to take the trade again, right? When we are ongoing trade, it's just one trade, okay? So this is going to be the first instance where the rolling sum is greater than or equal to 10, at least 10, okay? So I hope everything is clear for you, and let's begin. So we go back to our coding again on the pie chart file. Then we're going to add another interesting condition. As I had shared with you earlier, I wanted to make the buying condition for a particular candle. Right now, that particular candle should be what? That particular candle should be having a low which is lower than the upper band. Okay. So what we're going to say is we're going to say below upper. So let's just call it below upper, and let's just code it. Okay. So here we go. To the time. And now makes sense. No. Okay. So below upper is NP dot n. So this time we're going to take the low is somewhere below the upper band. The upper band had already encoded while we were coding the conditions, sorry, the indicators as upper. Okay. So select it down. And wherever this happens, we encode it as 1, otherwise as 0. This is the vectorized format, but eventually we're going to also make a for loop for the backtest. Okay, one more filter was the RSI filter. So as I said, I don't want extremes happening anywhere, although there's a less chance of that kind of thing happening. What happens when the price swiftly moves super swiftly and then a signal comes? I don't want that. So I'm going to do what is I'm going to say RSI filter. Okay. So np dot where the RSI is less than 90. Now RSI is less than 90 where? In the last 10 candles. Not in the immediate candle, but also in the last 10 candles. Let's just do that. So in the immediate candle, obviously, RSI 90. I'm already avoiding the immediate candle blow up if that happens. I'm already avoiding it with the below upper filter. So I'm going to make this filter, the RSI filter, a little more sophisticated. I'm going to make it for the last 10 candles also. So in the last 10 candles also, it should not have happened. So what we're going to do is we're going to call this RSI threshold. So we've defined a threshold over here. Is there a spelling mistake? Replace with threshold. Threshold, yeah, sorry. And let's just make the RSI filter over here. So we have threshold is 90 and np dot where this threshold has a rolling 10 period sum which is less than 1. That means this should not have happened in the last 10 days. And wherever this is happening, we'll encode this as 1. So we have given ourselves another filter conversion. Now let's just do something. Put all of this together. Okay, just put all of this together. Right, data by underscore condition. So what are by condition? Right? What is a by condition? A by condition is anything dot where this is true, 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 as well as this is true. This is a by condition. Okay, so let's just do this over here. Okay, understand the by condition better. So we need to make sure that we are sustaining above the MA, and we need to make sure that we are below the upper and we are above the 100 MA. So all of this we need to do right now. So let's just make individual brackets for this and get them together with and. So right now, first thing is we want above underscore wherever this is equal to 1 and above score 100 wherever this is okay. Should have added another bracket over here, which I did not. So I will be back to here. Now the extra close bracket and open brackets, open parenthesis 7, and sustain underscore 20 wherever this happens. We make detail clean coding, we do detail clean coding, so we make spaces wherever we're supposed to have spaces. Okay, for the button diagrams. So this is done. Another note, this is data. So below upper, low underscore upper equal to 1. There is some spaces here and another open parenthesis data filter sports underscore filter equal to 1. Okay, there we go. So we have all of this with us. Okay, and why is there a red line over here? Probably this is open back close bracket, open back a close bracket. This is done, this is also done. Okay, because if all this is true, encode respond, otherwise 0. So this should work. So maybe let me do that. Hang on. The red line should not come up with this. Okay, this is showing me an unresolved reference because I'm using some of the conditions which are encoded over here. So later I think this should be fine. Okay, so let's just let it be like this for now. Right. So we've completed this. I have done. No, it is already written. Okay. So by condition, let's just revise again. What do we need? We needed a above 20. We needed an above 20. We needed an above sustaining above 20. We needed above 100. And we needed a below upper. Okay, so this is true. And we need the RSA filter. So what I'm going to remove from this is I'm going to remove the above 20. And I'll tell you the reason why. Sorry for the correction I have to make. It's already quite a task to code and write, think and talk at the same time. So anyway, the reason I removed that is so that because it's already sustaining 20. And if the price mellows down a bit and there's a small correction, I get slightly lower prices. And that is where I enter. Okay. So from that angle, this is my perspective. Okay. So we have coded the buy condition. We'll just run the code to see if there's any problem. I thought so. So there is an unmatched parenthesis. So how come? Okay, so this is matching up with this. And this is with this. Should run this. It's important to keep the guidelines and everything. Voila. This is working so beautifully. We ran through our code and there are no errors, which is good. Coded quite a bit. Now we automatically have prepared data, coding indicators, and again I should have done this. That coding condition. Coding condition. And we pass the data frame through that, and ultimately we write the code along with this. So let's see if there are any errors, anything disturbing us. Yes, there is something wrong over here. So there's a key error, RSI. Even though we have defined RSI, so I think we have named it earlier RSI underscore 14. And here we just return RSI. Yes, so show work out. Perfect. So this is what that. So we've got all of this, and just let me make a calculation in front of you. And that calculation is that in a particular, I have to backtest this too, right? In a particular month or a particular year, how many candles do I have, which are the hourly candle? So because my backtest period is 2, allow me to just share the calculator and make small calculation quickly. So there's 7 hours in a day from the data point of view of trading market as in India, the Banknifty is trading, and there are 5 days a week which are working week. Or rather, let me just take 22 days a month. 7 into 22. So these many hours in a month, and there are 24 months in 7 years. So we get 3,696. Okay. And then we subtract about, there are about easily about 15-20 market holidays. So let me just subtract 40 from it and get a nice round figure. 3656 here. So let's just get 3650. Or let's just keep it 3656. Okay. So let's get back to our Python project. We're going to say df over here after coding the conditions. So df equal to df, as I said, equal 3656. So minus 3656 to till now is our new estimate. Okay. So we are prepared with the data frame like this. And now our time to backtest. So for backtesting, I'm not going to create a function. And so how beautifully all the functions are created. And while they created very beautifully, we have used them at once. So a lot of things have happened at once. Similarly, we could code a backtest function also. But since we're not doing that, we're going to run a for loop. And first we have called these functions and done our job till here. Okay, so now depending on this thing. So let's just make a small comment. Running backtests now. Okay, so let's run a backtest now. Makes sense. So if you run the back test, let me call variable called position, and we say it is 0 right now. So later we can encode position or as 0. Okay, just a second. Okay. So we have a position later is going to help us. We're also going to create a new column, which is going to be an empty column, which I'm going to write as df, because we are calling it data frame, df position, and make it an empty. Let's make a new list, spoil returns underscore list, and we're going to make it an empty list. We're pretty much done. And to count the number of trades, let's set count to 0 and count underscore for the positive trades equal to 0 then, and count underscore like that way equal to 0. Okay. So this is all we have prepared, and now we'll go run through each one of these rows through the index. Okay. So let's write for I in df dot index. Okay. And we're going to do that. So first is my buy condition, because when there is no buy condition, there is no trade, there's nothing to backtest, right? So first thing first, my buy condition. What is my buy condition? So if position is 0, which it is in the beginning, then I'm going to create a buy position, right? And the f buy underscore condition. So I already had defined a buy condition over here. So the ith index for every iteration equal 1. So all my conditions are together in this, and this is for loop. Okay. I don't understand why this red line. So let's find out. Expected. Okay. Okay. Okay, this should be equal. If this and this if position is 0 and the if by condition equal to 1, then so still not understanding what is working. Actually, before that, let me just define a few things so that I make my work a bit easier. I'm going to define close as df close ith index will do say low is equal to df low again ith index, and that should work. And for the position column, so df. So what I'm going to do is I want to make sure that whatever the position is over here is reflected over here. And to be able to do that, I need to define the position column as the integer value of the POS or the cost. Okay, and I need to do that within the for loop. So within the for loop, is equal to integer value of the position. So I think this should work out. And if the and to be able to understand why the high condition is not working out, let's just go over here and see if it is actually go. I think it is the yes, extra space which I need. That is why with Python we got to do like I think we can't play around with Python. Okay. So if this is true, let me create a variable called I, or let's just call it BP is equal to close. So if these conditions are met at the close of the candle, I will buy this. And since we're dealing with the hourly candle, we're not looking at the look ahead bias as something too serious. We could buy in the last second or the last few milliseconds at the end of the candle close or the first few milliseconds of the next candle open. Okay. So buying price is equal to close. What do we register over here? Let's just register count because this is the total number of trades. So count becomes plus equal 1. Every time we come into this block of code, count is equal to plus, or for the people who are very, very new, count plus 1. Okay. These two things I have to set very, very clear. I hope this is clear to you. I know it's a bit long video and could be tiring for you to code for so long, but trust me, it is going to be worth it. Okay. And what else is happening? Now the POS is set to a new number. The POS variable is set to 1. Okay? So this is the thing. Now let's move on to the next block of code and rewrite another if. So let's just make it elif. If this is not true, if position is 0 and this is 1, but if this is not true, it will move on and check this. And in this line, we write first the stop loss condition, because as we are iterating through the rows, we need to first set the stop loss and make ourselves a bit conservative in our approach. So if there is an existing position, okay, and I forgot to share with you one thing, we're going to have a target stop loss on the basis of percentage. So our target is going to be 6% and our stop loss is going to be 3%. Okay. Now, in general, professionally, we do that after some research, but I'm skipping that part and I'm coming straight to the target and stop loss with a ratio of 1.1:2. So 3 is the 3% stop loss and 6% target. Also, to make sure that there are no spike highs, I'm going to make sure that we exit the trade at the close. Anyway, when there's a profit. So anyway, let's just do one more thing over here. We define the high equal to, just a second. Okay. So the F high 1. Okay. So this is my thing done. So if position is equal to 1 and the low, so basically and the low is less than our stop loss. So what is the stop loss? That is the close price multiplied by the stop loss. Low is less than VP into SL. Okay. If these two conditions are true, we got to exit the position. We exit the position at where we exit the position on the selling price. Okay. Though SL is equal to, or let's just make it SP. SP equal to close multiplied by close multiplied by sorry, close buying price multiplied by the stop loss. Okay, just a second. Just a second. Okay. Mm. Yep. So yeah, this is the surprise. And what we're going to see is we're going to get some sort of return, right? So first let's set the position back to 0. We're going to set some return, so we'll call it return. Let's not try return because Python identifies it. So let's just write R is equal to the sell price divided by the buy price. Okay, the sell price divided by the so if you have a sell price and a buy price, how does this work? Just to explain to all of you, if we have a sell price and buy price, how do we calculate the percentage return? Suppose selling price is 105 and the buying price is 100, right? So generally our percentage return would be something like 105 divided by 100, it will give us 1.05. So we need to minus 1 from this and we'll finally get 0.05. Okay, so this is how it is going to look like. So we'll keep it like this for our coding purpose also. So for in that sense, what we're going to do is we're going to do this divided by this, SP divided by BP minus 1. Okay. So this is it, guys. This is done. And now let's have the target. So LF position is equal to 1, and instead of the stop loss, target by estimate, phi is greater than uh, BP multiplied by PGT, which we'd already defined. Again, we have the selling price equal to BP multiplied by PGT, and we have position equal to 0. We set the 0. We have got R is equal to the SP divided by BP minus 1. Okay. Sorry for the disturbance. Sorry. Coming again. So we've got our positions, our exit conditions, entry, everything set over here. So every time we take the trade, this counts +1. Now what happens every time we exit the trade? So let's just say we have got the return, and every time the return, so we're going to write another if loop here. If R is greater than 0. So in the case where we have hit a stop loss, the R is going to be less than 0. So why not just uh, say that, okay, the count count underscore negative variable is count negative +1. Okay? And similarly over here, every time we get a target, this thing will be count positive. So let's just say count positive is equal to count positive +1. Okay, we've got this, right? So this we've got. Now what we're going to do, we have a list, empty list waiting for us over here. So we're going to append each and every return that we get. Okay, so we get the number of trades through this count, and the positive trade through this, as well as the negative trade through this. Okay. So moving on. Just excuse me, I'll just get some water. Give me a minute. Okay, guys, I'm back again. So, uh, yeah. So as you can see over here, we've done the needful. Okay. So position equal 1 and high is greater than our target. So we've got a target hit. And where do we exit? We exit at the target. Okay. Oh, one more thing I would like to say. Just a second. Okay, sorry guys. Sorry for the glitch. So what we're going to do as another condition is we're going to write that and if the number of uh, the closing values, okay, if the number of closing values is just to make sure that if we have an open position when the last closing value is iterated through. So sorry, I was getting so many phone calls suddenly and I had to go back. So I just got a bit here and there. Okay. So uh, if this is 1 second. So what we're going to do is we're going to define another variable now, and we're going to call it a 0 in the beginning. And as I've done it before, so because of lack of time moving up a little bit with speed, we're going to write another elif statement. I'm going to say wherever the num, which is going to come in the end as a num plus equal 1. Okay. So whenever we're going to find this happen, we're going to just simply exit at the close. And we're going to re-register POS as finally 0. And we're going to say that return equal to SP by BP and -1, of course. And for each of this, what we're going to do is we have got a returns list waiting for us. So when the returns list is waiting for us over here, we have to append this return list with constantly every return that we get. So suppose we get a return over here, right? So we're going to say return list dot append, and we're going to write R within this, and just simply copy this across over here and over here. Okay. So once done, we can finally come to a conclusion that our backtest will be done. And in the end, let's just pretend, so we just print our return underscore list and run this one. So our backtest is iterating through all the different 3,656 points, and we see that there is a return list which is an empty list, which is surprising. We've got an empty list as an output. Maybe there is some escape which we have. So, okay. So we've got R over here. Returns list is appended with R. Again over here. Again over here. Okay. If the buy condition is equal to 1, and position is 0, we reset the position to 1, we reset the position 0, we reset the position 0, we reset the position 0. If none of this matches, then how can we have an empty list? Something to think about. So, probably some mistake I've made somewhere or the other. Have I forgotten a particular point? I'm just trying to understand. Okay. Code seems to be fine. So we bought at the close. Okay. Otherwise, we do stop loss. Yeah, so guys will be stop loss. Other guys will be target. And then define the target on the stop loss and say position price between target SP target R is equal to SP by VP minus 1. Now, be the case. Okay. Define the low, define the high. Define the close as the high, this thing. R is taking no value and getting appended to the return score list. This is something weird, should not happen. Okay, maybe there's something wrong with this. So let me also print the f.head. If there's something wrong with this, then there's something wrong with the entire page. No. Seems to be fine. Starting 2021. Around May, around February. Return list is set 0. This is print count as well. Seems like there's no trade being taken. Maybe something wrong with the buy condition. Yeah, there's no way to paint it. So there's something wrong with the buy condition we need to figure out. So if we go back a buy condition, everywhere we are very above 100 net, below upper net, staying above the 20 net, sum is greater than 100 net, and below upper. So okay, so no, it's less than upper. Mm-hmm. It's 90. Just wait. I'm just wondering where it was like code would otherwise be working fine. If the time is to 0. Compute of this is met. Through these functions, we define the DF. Something wrong with the code. Just give me a second. Define it before the formula. Okay, I get this. So I define this before the formula. After the formula. So should not be much of a problem. Okay, here is where the mistake. Every position will take. Now close. So we start down there. No, why would not it iterate through even one particular this thing? Did I make a mistake while doing something with the date, or did I make the mistake by doing something with the time? I don't understand. Answer threshold is also fine. Okay, now I get it. Maybe something works out over there. I think with coding eyes sometimes just government disco list is there. We have not taken a single position. We do try to do the backtesting. Position is 0. Out of the parentheses, should not have been relevant. This is not even iterating through one loop. So the problem is going to be above this. Okay. Starting to understand why it was better to do it on Jupyter notebook. Okay. Prepare data. Official 0. Call this DF, we call this DF. This is very important. Wherever it is greater than 90, I want to avoid those areas. So I did a less than 90. And now I should get the results. I'm pretty clear about it. So I should get a long list of returns or long list of returns. So we've got a number of trades. So we've gone on over here. This is a long list of returns. So let's just print length, the length of the returns column, returns list, and play around with the returns list after this. Because we've got this, and thank you for your patience. So this got approximately 23 trades, and we got number of trades and as well as the length of the returns is 23. Now, what we're going to do is we're going to optimize this a little bit, small few changes here and there. So first is I'm going to make this returns list. It's equal to pandas series, right? Pandas series, and but then what I'm going to do is I'm going to find the cumulative sum of this. So this is going to print the cumulative sum of the returns and giving the total return. So the total returns are over here. Now, ladies and gentlemen, I had promised you. What happens is when you're taking a trade on an instrument like Banknifty, and in the sense that we're not looking at options, we're looking at spot data over here. The futures data is going to replicate that. Okay, so I'm going to get going to print a few other things as well. What I'm going to print? First of all, let's just get a neat and clean graph of how the returns will look like. Okay, so what I'm going to do is I'm going to first multiply the returns by 4. See, generally the market gives us about a leverage of 5 to 6 times. So for a 10 lakh rupee contract on Banknifty right now, 10 lakh plus contract, you need to actually have a entire this thing. The capital or the margin requirement is 1.5 lakhs, which is actually more than 5 times leverage. So let's just assume 4 times we are getting the leverage, and therefore the returns are going to get inflated. Okay, so the return on your margin capital is going to inflate like crazy, but we're still taking just 4 times, a bit conservatively. So that will make a lot of sense. Okay, so now what we're going to do is we're going to plot a graph. Okay, and we're going to do returns list, the cumulative sums of the return list, and we're going to just sort of so this is returns list dot cumulative sum. We're going to plot legend is true. Title would be returns. Okay, and we save this as a PNG file as returns underscore cumulative. Okay, and we're going to run the program again, and it's going to save it to us in our file over here, as you may be able to see in a second when I share the screen. So Python project 3. Okay. So once again, guys, sharing the screen. Here we go. Probably for me, for myself, I need to make it bigger. So this is the returns, cumulative returns. Now sharing the screen over here. This is how the returns cumulative returns look like. Okay, so we got in 2 years, we got some really decent number of trades. It's 23 trades, and we got a cumulative return of about 25%. Okay. And we multiplied it by 4 to get the understanding of the leverage encoded in our coding. And now what we're going to do is we're going to create a column for the strategy returns. And in the vectorized format, we're going to again plot something which is alongside the the Banknifty returns. So the Banknifty returns by themselves were what we need to find that out. Okay, so let's just call it buy and hold returns. So b underscore h underscore returns. Okay. And this is going to be np.log. The logarithmic returns are additive, so we're going to do a dot cumulative sum later with a clear ID. So we will close. So this is going to be close divided by the close in the previous column, and for that we use the dot shift function. Okay, so this is the buy and hold returns column, and we're going to write the strategy underscore returns column, which is simply going to be the multiply by multiplying this and the positions column. If you remember, we have created. So we're going to have the positions column, which is the linear position, and we get a total of these. Okay, so here what we're going to do is we're going to simply print buy and hold, right, a comma, and print the b underscore h returns dot cumulative sum and dot ilog to get into the last index. Okay, similarly we're going to do the same thing for our strategy returns. Okay, dot cumulative sum dot ilog minus. Okay, and it is going to run the program, give us the final total according to the vectorized format. It's going to be slightly below or above the 23 value. Okay, there's something wrong. Has no attribute dot ilog. Probably I have no, it should have ilog. Why will not have an attribute for ilog? No attribute for ilog. Yeah, because it would work. It works like this, or this is okay. Got it. But the problem, so the problem was over here. Also missing parenthesis after cumulative sum. Okay, cumulative sum. So now we're getting on the right at the bottom of this. We're going to get both the total. Okay, so the total over here is around 22%, and buy and hold returns is eventually going to be um, just 10.43%. So we're going to multiply this both by 100, so you can get a better picture. Okay. Yeah. Now what we're going to do is we're going to finally recreate the strategy data as a leverage format. So the strategy data is actually going to be that strategy data uh, multiplied by 4, because we're assuming 4 leverage, and finally we are going to reprint that over here. Allow me to just put it over here, and we're going to reprint it with the leverage. And for the sake of visualization, we're also going to plot the needful. Okay, so it's going to come around 90%, whereas buy and hold gave us only 10%, our strategy gave us 90%. And finally, to be able to plot that, just as I used this syntax, I could simply copy paste this, and here I'm not doing just this. So dot plot method I'll be using for EF buy and hold returns, comma, so, and strategy returns, and package dot native sum and brackets here, and we're going to title this as returns comparison, and like this is compare this with png, and we're going to save this. Now, mind you, probably have to share my entire screen together for this. So this is how the compare plot looks like, which is basically, you can already see the compare plot. Okay, and this is how the strategy returns alone look like. Okay, so you can see that there are massive drawdowns in between, but overall the strategy is profitable in a matter of 2 years, and there is leverage involved, but there is no compounding involved. Our calculation, we have not taken compounding into account. Okay, last but not the least, just to see how the entire thing follows the market, what we're going to do is we're going to just a second, go back to our coding screen, and without the multiplied by 4, we're going to just run the code again, and we're going to see that while we run the code again, this time we're going to see a different graph on our compare section. So we see the strategy returns are still beating the market, and the market is giving much lesser returns, but without leverage, this is the picture how it looks like. The shape still looks the same in case of returns, because we have not done divided by 4 over there, but this is how it looks like. So with the leverage, without the leverage, does make a lot of difference. So even the drawdowns have a little different effect when there are leverage. So you have to be careful about the leverage factor involved. All in all, assuming that you're going to use certain leverage, we're going to see how our thing looks like over here with the leverage. Okay, quickly let's go to a few more things. Let's go to a few more things. Okay. So total of almost 100% returns. And the number of trades. The beauty is that the trades which we have taken, the number of trades we've taken is not a lot. I want to print the number of losing trades and the number of winning trades. Okay. So count underscore negative and print count underscore positive. And just to note them a little bit on the side, we say, okay, losing trades. And similarly over here, say winning trades. Okay. And we'll run the code again. So let's see what are the number of trades which are winning versus the number of trades that are losing. So we have got 10 winning trades and 12 losing trades. And let me show you some magic. Magic over here is, I don't do this while I'm doing research, but just to show you, if I convert this to a 4%, I convert this to a 2% loss, and now I run the entire thing. And we see the number of trades will be different, and the buy and hold is going to give different results, and the strategy is going to give so far lesser results. So even though the point what I'm trying to make over here is that because our targets were much higher and our stop loss was in a 1:2 ratio. So even though almost our profits are almost equal to a number of losses, okay, or not, actually our winning trades are more over here. That's okay. Sorry, I made a mistake. This would be 1.06. So even though our number of winning trades and number of losing trades, there is not a big difference in between them. Still, we see that we are having net gains because the profiting trades are giving us double of what our winning trades are not giving. So again, coming to our plots over here. So this is how the strategy return looks like. And if 2 years back you had put, suppose, taken 10 lakh rupees worth of this, it would have become 20 lakh rupees. Given that everything else is unchanged, and one more thing is the number of trades are less. I have not calculated the transaction cost over here, but since number of trades are less, it is pretty good. So nothing to worry about. You can connect with us in the near future. You can connect with my team. You can connect with me. We are having a new course on algorithmic trading, in which there will be a lot of rigorous stuff, backtesting, and we're going to start it from the basics of Python for finance and lead it towards a place where you can deploy your own trading strategy, create your own trading strategy, model it, backtest it, optimize it, and then also deploy it. Okay. So thank you so much, ladies and gentlemen. It was a long video. Hope you had fun. Take care. Goodbye. Enjoy.